Excuse me. All right, so let's go ahead and begin. Mhm. We are in the last chapter, chapter 8. And you can see there are plenty of slides, but all of them are not too long. So it won't take us that long to get through all of the material. Any announcements? I don't think so. I'm not checking anyway. All right, 1.8, introduction to statistical tests. Anybody knows what a statistical test is? A statistical test is the idea that if I take a sample, I know for a fact that the sample most likely is incorrect. Yes? The classic example, let's say I want to know how well students are doing in my tests, right? If I take 10 students, I get an average. Well, is the average the correct average for the entire class? Most likely not. Yes, it'll be pretty close, but most likely not. Yes. The thing about statistical tests right here is when you take that next step, when you try to make a change to the environment. So let's say I begin giving my test one now for 5 years. I decide, hey, I'm going to make a difference this year. I'm going to change some of the questions that are on the test. Yes? Well, I take the test the next year. Let's say previously the average was 80. I give the new test right here. Maybe the average is now 90. Yes? Question is, did the students actually do better on this test? Well, on the before they were getting 80, on this next test, they got an average of 90. Did the students do better? And that's the problem. The problem is we actually do not know because there are actually two possibilities. One, the questions on the test were better aligned, and because of that, students able to do better on the test. Yes, but it could also have simply been random chance, right? It was just that this group of students had a better background of statistics, or this group of students, they guessed right on a few more questions and they got higher, right? And so it's not necessarily that the test is students are doing better. It was just random chance that caused the higher grade. Yes. Maybe next year when I give that same test, the average is going to be 70. Maybe the year after that is going to be 75, right? And so the question of do the students do better is not simply a question of, hey, is this score higher than the other ones? It's a secondary question is this due to the changes I made, or is this due just to random chance, right? And the statistical test is there to help us distribute between the two concepts. Is this I just got lucky this one time right here, or is this change that I made really affecting the population I'm looking at? Questions there? All right, so the first thing that we do right here when we're doing a statistical test is we have these two concepts of something called a null and something called an alternate hypothesis. Now, I do need to apologize right now. On these slides, there are going to be a lot of long sentences. They love telling stories for these things for some reason. Okay, I know the reason, but a study published in the Journal of Air and Waste Management Association reported that the mean amount of particulate matter produced by cars and light trucks in an urban setting is 35 milligrams of particulate matter per mile of travel. Suppose that a new engine design is proposed that is intended to reduce the amount of particulate matter in the air. There are two possible outcomes. Either the new engine design will reduce the amount of particulate matter, or it will not, right? They designed the engine, but literally all the engines before are really good, so it's not going to make much of a difference, or it will significantly reduce the amount of particulate matter that the cars output. Yes? These two are called our hypotheses. One of these hypotheses is called the null hypothesis or the nothing change hypothesis. One of these is called the null hypothesis, or the nothing changed hypothesis. And the other one is called the alternate hypothesis, or alternately speaking, or on the other hand, hypothesis. The null hypothesis is a working hypothesis that states that there is no real change based upon what we made, i.e., the currently accepted historical value is the correct value. So let me put this in context of the car. We made the new engine, we put the new engine on the road, we get how much particulate matter that's coming out. A null hypothesis will say this car engine is no better than all the other engines before. This car engine is going to put out the same 35 particular matter as the other ones did before. Because of this right here, your null hypothesis will always carry an equal sign. We use HO to represent null hypothesis. In certain regions, the number is 0. It's called a null. Yes? Right? H stands for hypothesis. So this is the hypothesis 0. The person who did this first called hypothesis null, or the null hypothesis, right here. The alternate hypothesis, on the other hand, is the change that we are trying to see. In our first example, the change we're trying to see right here is less than, i.e., the state of output from the cars is going to be less than what it was before. Yes? Because of this right here, your alternate hypothesis right here will use one of three signs. It'll either use not equal to, it will use less than, or it will use greater than in your null hypothesis. The key thing right here is that your alternate hypothesis is against the null hypothesis. It is trying to say that we have something that is different from the currently accepted historical value. All right? So your null hypothesis is nothing. Nothing has changed. Your alternate hypothesis is something has changed. The number is either greater than it was before, it's going to be less than what it was before, or just simply going to be different from what it was before. Questions there about the difference between the null and the alternate hypothesis? The alternate hypothesis right here, we use the letter H1 to represent our alternate hypothesis. So we have hypothesis 0, your null hypothesis, and then you have hypothesis 1, your alternate hypothesis. As a scientist, what you are trying to show is that the alternate hypothesis is what has changed, is what has now happened. So in our example right here, our alternate hypothesis is that the amount of particulate matter will have decreased, or it would have been less than what it was before. Questions there on the concept of your null hypothesis versus your alternate hypothesis about your H0, your HO, as opposed to your H1. The hypothesis that nothing has changed versus the hypothesis that something has changed. That's either it's now larger, the amount we're looking at is smaller, or at least it's different from, not equal to, from what it used to be before. Questions there? Oh, cool. Again, your null hypothesis is simply a statement that things have not changed, while your alternate hypothesis is trying to say that there is evidence that things have changed, that there is evidence that we should not accept the null hypothesis that the things have not changed. Now, here's the thing. The null hypothesis is going to be assumed to be the current truth, right? Remember, in our case of our engines, we have 50,000, 100,000 of these engines running on the road. We know that these engines put out 35 particulate matter, yes, per mile driven. We know this, right? We know for a fact we worked hard at building engines, and we tried to build the best engine that we could. And so we know that this outcome right here is a strong outcome. Thus, for us to reject this, reject the null hypothesis and switch to the alternate hypothesis, we need what is called strong evidence to go against the null hypothesis. All right. Now, what we mean by strong evidence, we'll tell you in a second. But the key thing right here is the assumption is the null is true. And then we have to look for true evidence, true facts that point us to our alternative hypothesis. All right, so let's look at some examples of generating null and alternate hypothesis right here. A car manufacturer advertises that its model gets 47 miles per gallon. Let mu be the average of the mileage distribution for these cars. You assume that the manufacturer will not underestimate the car, but you suspect that the mileage might be overrated. Can you generate a null and alternate hypothesis for this scenario? So let's underline some things right here. First things first, your car manufacturer is saying that the car is getting 47 miles per gallon. Yes? All right. And then let's look down here. You suspect that the mileage might be overrated. So if the mileage is overrated, what are you trying to say about the mileage that you're getting from the car? If you drove that car and you got an average, what average number of miles would you suspect that you would get from this car if the manufacturer is overrating their claims? You expect that a number will be, let's use the words greater than, less than, or not equal to. You'd expect that the mileage that you get from the car will be. Now, he said overrated, right? So let's say you buy this car and the car gives you 67 miles per gallon. Were they overrating their statement? No. So if I overrated, I'm trying to say that it's going to be less than 47 miles per gallon. Right? Think about it. If you believe they're overrating, right, the number they're giving you is higher than what the real number is. Yes? Yes? And so this right here will be your alternate hypothesis right here. Questions there? Comments? Before we try again. Queries? Concern? All right? Let me try again before we go into left tail and right tail and all the stuff right here. So let's say right here, I have a business school. No, let's not go with the business school example. Let me make up my own example right here. Let's say let's pull on something that you guys basketball season is about to start right here. So let's say right here that the coach right here predicts that his team will win 48 games this year in the NBA, National Basketball Association. Right? But you've researched the team, you've done all this hard work right here, and you believe that the coach is underestimating the number of games that the team will win. You believe that the coach is underestimating the number of wins. Right? Because coaches like to do all the time right here. They don't want to say, "Oh, we're gonna win every game this year." They don't get held to that standard. So they, which is okay. We expect to win around 48 games this year, right? But you believe that they're underestimating the number of wins that they're going to have right here. What will be the H0? What will be the null hypothesis for this statement right here? The key thing to remember is that the null hypothesis always uses an equal sign. And so my null hypothesis would be that the average number of wins for the team is going to be 48 games. Does it make sense right here? What would be the alternative hypothesis? What would be the H1 in this scenario? The mean number of wins for the team will be greater than 48. Questions there? Remember, your alternate hypothesis always is either greater than, less than, or not equal to. Questions there? That better? That better? Ah, good, good, good. All right. So now we can go into our tails, right? There are three possible alternate hypotheses, right? The first is called a left-tailed test. Where have we seen left-tailed before? Right? We're shading numbers that are less than, yes? You have your left-tailed test. And then we have when you are doing a left-tailed test, you're looking for stuff like less than, below, decreasing, underfeeling, overrated. All of these right here means that we have a left-tailed test, right? The alternative hypothesis is that the true number, the true mean is less than the number that's actually happening right now. On the other hand, you have a right-tailed test. Oh, that's right. Your left-tailed test right here is called a one-tailed test because you have one area of rejection region, one area where bad things can happen on the left side. Then we have a right-tailed test. A right-tailed test right here is greater than. You look for keywords like more, above, underrated, increasing, right? We believe the coach is underrating the prospects for the team for this year. That's why we said greater than 48 wins, right? On a right tail test, we're shading the right side of the curve. In other words, that's where our rejection region is. That's where our error is going to be. And for these right here, your alternate hypothesis is that mu is greater than mu zero. And again, what mu zero is right here, that's your numerical value. In our example, it was 48 wins. That's what that mu zero is right there. Right? This is always mu, right? And of course, this again is a one-tailed test because all our error is on one side, on the right side. And then finally, we have a two-tailed test. In a two-tailed test, we're using the not equal sign right here. And again, the keywords right here is different from, or simply has changed, but we do not know what direction it changed. It may have gone higher, it may have gone lower, right? Let's say, for example, the SATs, right now, the current average on SATs right here is, say, 650. You guys know that they're switching to an all electronic version for the test now? You guys know that? In theory, it's supposed to be the same test, supposed to be the same scores, right? But you can imagine a scenario where that can cause the scores to be different. Yes? But we don't really know if it's going to be a harder test, i.e. the score is going to fall, or it's going to be an easier test, the score is going to stay the same, right? We don't know because it's supposed to be mimicking, supposed to be the same test. But it's just been giving a different format. And so because of that, we would need to use a two-tailed test to test the efficacy of using that new model for testing students. Make sense? And so for two-tailed test, your error lies on both sides, your right and your left side right here. So you take your alpha, you divide that by 2. We'll get to what alpha is in a second because it's split on each side. You have 2 times you can reject the null hypothesis. And again, this is written as H1 is mu such that mu is different from, in the example we were talking about here, I think the average for your the math section for your SAT, I think is like 600. So we're saying, hey, now that we're using this new test, our alternate hypothesis is that the average will no longer be 600. Question there. All right. So let's go through some examples right here, and let's see if we can determine if it's a one-tailed test or a two-tailed test, determine if it's a left-tailed test or if it's a right-tailed test. All right? So, like I said, lots and lots of reading. Please don't go to sleep. I'll tell you. Boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. State the null and alternative hypotheses. Somebody wants to help me out with the null hypothesis? What is my HO? Mu will be, what's my HO? Equals 20. Let's do the hard one now. What's about my H1? Mu is I have several people saying the answer so softly to themselves that I can't hear. I'm an old person, people. It's going to be less than 20. How you got that lovely answer? Because what he believes or what he thinks right here is that the company has changed their manufacturing process, right? And when they make that change to the manufacturing process, the machines are putting less than 20 in there each and every time. All right. So again, equal sign right here, mu is equal to 20, and then H1 mu is less than 20. Questions there? This is a left-tailed test. All right. Last year, the mean monthly rent for an apartment in a certain city, not Tallahassee, was $800. A real estate agent believes that the mean rent is higher this year. State the appropriate null and alternative hypothesis. Anybody wants to help me with the null hypothesis? HO mu is equal to $800. And what is my H1, my alternative hypothesis? Mu is greater. Is it greater than 800 or is it greater than 801? Or is it greater than 855? The numbers are always the same. So it's going to be greater than 800. All right. Questions there? Yeah, one of these days, rent's going to go down in let me say it out loud because I'm just lying to y'all. All right, so your null hypothesis is that the mean is 800. And again, expect that it gets higher. So your alternative hypothesis right here is going to be 800. Again, what's going to happen is the real estate person right here is going to go out into the community and ask people, hey, how much are you paying for rent? Right? They take all the numbers in and then they get the average. That numbers that they're taking in, that's called evidence. Right? So let's say they got all these people, they took an average and they got an average of say $801. Is that strong evidence that the cost for living is higher than $800? Not really, right? Right? If that maybe taken like two more houses down the block, it might have come back down to 800. Yes? But on the other hand, they go out there, they talk to all these people, and the people come back and say, look, we're paying $950 on average. When you add them all up and take an average, is that strong evidence that the rent's higher than 800? Most likely, yes. That's a significant jump difference between the two scores, right? And so that's what we mean right here by having strong evidence. We have to go out there, we have to sample the what we're looking for in this case right here, rent, and then use the average of our numbers of sample to get to make an argument as to whether or not this is no longer true, right? Because remember, the assumption is that the null is true, right? It's been $800 for the last 10 years, right? You can't simply say, oh, it's 801 now, so therefore it went up, right? Question there. Again, this is a right-tailed test. Scores on a standardized test have an average of 70. Some modifications are made to the test, made electronic. An educator believes that the mean may have changed. State the appropriate null and alternative hypothesis. Anybody wants to raise their hand and tell me what the null hypothesis is? HO mu equals 70. Thank you. And anybody else wants to give me the alternative hypothesis? Anybody else? It is not equal to how much? Not equal to 70. Remember, the two numbers right here will always be the same. All right? Questions there? This is a two-tailed test, right? Not equal to means that I error is split on two sides. Not equal to right here. And this is going to be a two-tailed test. Questions? All right, cool. The purpose of a hypothesis test right here is to determine how likely is it that the null hypothesis is true. Now, here is the thing right here. The idea right here is that it's kind of like a criminal trial. What happens is we're putting the null hypothesis as the defendant, but the null hypothesis has the advantage of it. Basically, we have to believe that the null hypothesis is true, i.e., it's innocent. Yes? And so what happens right here is we have to present evidence. And again, like I tell you, the way we get evidence is to go out into the real world and gather numbers, right? Like say, for example, I'm teaching this section different from how I did before. Maybe using computer side assisted graphics to teach this section right here, doing a different way, right? I then have to have maybe 100 students take the next test, and I can use that as evidence, right? Now, the evidence may speak one way, the evidence may speak another way, right? Maybe my average before was 70. Now that I taught it this new way, my average is now 60, right? Or maybe I taught it this way right here, maybe my average is 90, right? The evidence, I can't control what the evidence is going to say. All I can do is just go out there and get those numbers, all right? Once I have the evidence, I can then use the evidence to strongly indicate which way do I go. Because remember, there are only two options. It's either the null or the alternative hypothesis, yeah? But guess the thing right here. Guess what you think they mean by strong evidence? Guess what you think they mean? So let me put it this way. So let's say I've done all of this information. I have my null, I have my alternative hypothesis, and it's all an 80% chance that the null hypothesis is true. Is that strong evidence to reject the null and then change to the alternative hypothesis? There's an 80% chance that the null is true. Should I stick with the null or switch to the alternative hypothesis? Stick with the null, right? Well, it's about 50-50. It is a 50% chance that the null is true, 50% chance that the alternate hypothesis is true. Which one should I stick with? Which one should I stick with? The null, yeah? What's about 20-80? 20% chance that the null is true, 80% chance that the alternative is true. Which one should I pick? For us in this class, we actually still go with the null. The idea is that when we say strong evidence, we're actually looking at a 95% split. Only 5% chance that the null is true, 95% chance that the alternate hypothesis is true. When we say strong evidence, that's actually what we're doing. We'll show you how to calculate the percentages a little bit later, right? But that's actually what we mean by strong evidence. The idea is that the null process has been true 20, 50, 100 years. You can't just come in one day and do one change and say, oh, wait a minute, all of this stuff, just throw it out the window, right? And so because of that, when we say strong evidence, we want to say the probabilistically wise, it's almost no chance that the null hypothesis is true. Okay? Questions there? But again, we'll show you how to calculate the probabilities in a second. But the key thing right here is because the null hypothesis is being given the assumption of innocence, we want to be absolutely sure we have a very high threshold before we switch from the null to the alternative hypothesis. Question there. Yeah, I know. It was weird for me too. It's 80-20. We still going to 20. It turns out, though, a lot of time in terms of real life, a lot of these things tend to have other reasons why they happen. There are a lot of what we call confounding variables, right? A class did better, but it just so happened that everybody got a good night rest that night, or something else happened. That's why they did better. It's not because you're so smart and you're such a great teacher. That's not why they're doing better. Yes, and so because of that, we need strong evidence. In fact, if you move into the other realms, for example, chemistry, physics, and those kind of things right here, the threshold level even gets higher. The null has to be only 0.1% true, while the alternate has to be 0.99% true before you switch from the null to the alternate hypothesis. A lot of these chemistry and physics, all this nonsense they're saying about they found out these new exotic materials or whatever, they've done a lot of work before they can come up and say that this thing is true, right? Very, very high standards. All right. So basically, the way the process works right here is we start with the assumption that the null is true. And then we look for evidence from data that we have collected. After we look at this evidence right here, we have to decide whether or not to reject the null hypothesis. Again, everything is keyed off the null hypothesis. And if we reject the null hypothesis, then we will then assume that the alternate hypothesis is true. All right? And we've talked about right here how you reject the null hypothesis. You have to look at the probability that the null hypothesis is true. And we have a very, very high threshold before we can say, okay, you know what? We're no longer going to use the null. We're going to switch to the alternate hypothesis. Question there. In other words, we need strong evidence. Another way to put this right here is that, look, if the alternative hypothesis is true, then it's simply true, yes? And so, i.e., the probability that the null is true should be practically zero, right? That's another way of thinking about it, yes? If the alternate hypothesis is true, then the null hypothesis should not be true. So there should be a low percentage chance that the null hypothesis will happen. And that's another reason why it has to be a 95% chance that the alternate hypothesis is true for us to switch to. Question there. Oh, y'all thought the people didn't have standards? They just wrote their papers and said, oh, this number looks bigger, so I take this number. No, you got to do a lot of hard work right here. All right, so we're skipping ahead to the almost the very last step right here, because getting the evidence and evaluating the evidence requires math. So we're skipping that step for now. All right, so the final two steps right here. So based upon our calculations, we need to either reject the null hypothesis or fail to reject the null hypothesis. The reason why they use this language right here is imagine a scenario where the null hypothesis is only 10% true, right? There's only a 10% chance that the null hypothesis is true, but we're still sticking with it, right? So in other words, we say we just don't have enough evidence to reject it. It doesn't look like it's true, but we don't have enough evidence to reject it. So we simply say we fail to reject the null hypothesis. We never say the null hypothesis is true. All right? Questions there? And then once we've made that assumption right here, we make a conclusion or a claim. If the null hypothesis is rejected, the conclusion is that the alternate hypothesis is true. If the null hypothesis is not rejected, we don't say the null hypothesis is true. Instead, we say that there is not enough evidence to conclude that the alternate hypothesis is true. Remember, a 10% flip, there's only 10% chance that the null is true, but we're still not rejecting it, right? Because we just don't have enough evidence. Yes. So it's like possible for the goal to be 100% true. Yes, it's possible to have every single go in one direction and say, yes, the null is true. Because remember, that's actually more likely to happen. I'm just giving you these scenarios of low percentage. Most of the time, the null happens to be true. Because remember, the null has been happening for 10, 20, 40 years. This is what's been happening. So most likely it's true. So we would say like, we will still say, because of how this is structured, we will still say that there's not enough evidence to reject the null. Okay. The reason why is this: in those scenarios where the null is 100% already, we don't do research into those things because it's plainly evident that what's been happening is true, right? The sun's going to rise tomorrow in the east, right? We don't need to do research on that, right? And so what we tend to do researching is where we have questions. And so where it's normally not the case, that this thing tends to happen as in clockwork. And so you don't tend to get those scenarios where the null hypothesis is 100%. All right? And so that's why this language was developed. Anybody else? I think I'm running out of time. Yes, I am. So we'll stop right here. We'll continue moving forward. But before that, any questions? Let me just do this over here. I might be a little late to class today, guys. That's okay. I'm coming. I'm coming. Broadnax, Brown,
Here.
Dixon, Dowdell, Alias, Etienne, Gaudreau,
Here.
Germany, Gibson, Gear, Holt, Key, Trelly, Lewis, Lloyd,
Here.
Mall, Merriweather, Moore, Perez, Phillips,
Here.
Piper, Ramirez, Rowe, Roper,
Here.
Watts, Jackson, Williams, and Young. Did I miss anybody?
The unit 4 says chapter 6 because I wasn't here because I was sick. So I had lots of
Yeah, you go make it for 6. You can make my office out Tuesday or Thursday from 11 to 12.
Yeah, I could do that.
Okay, well then, fine.
Okay.
So I did that.
But send me those dates. I'll take a look at it. You think I just take it? I don't know how the dates are changing. This sent me. I'll take it. I'll take it.
Thank you.
Have a nice day. All right, man. Thank you.